तो आंसर क्या है आपका? सब्स्टिट्यूशन। वेरी गुड, सबको पता होना चाहिए। To form amide from acid and ammonia or amine, I have to carry out substitution reaction. But what is the problem here? This amine or ammonia is a very good base, and this carboxylic acid contains highly acidic proton. So this amine or ammonia abstract this proton and gives the ammonium salt. So instead of substitution reaction, acid and ammonia or amine shows acid-base reaction, and we know that the acid-base reaction is among the fastest reaction. That's why acid plus ammonia or amine, they do not form amide. This is a conventional chemistry. I will tell you later on which are the modern synthesis for the amide formation. Okay, is it clear? Then second thing, amide hydrolysis is irreversible in the sense acid plus ammonia or amine, they do not form amide. Is it clear? Is it clear? So when amide get hydrolyzed, what we get? Acid. In general मैं बात कर रहा हूँ. What we get? Acid plus ammonia. But in acidic condition we get different product. In basic condition we get different product. Because in basic condition, this proton get abstracted and gives the carboxylate ion. Okay, but if I use ester instead of acid, so this is ester. When ester react with amine, in basic condition, in presence of OH minus, so this is a lone pair. This lone pair attacks on this carbonyl carbon because this carbonyl carbon is electrophilic in nature. Pi bond is break, formed again. OR minus is leave. And this OR minus abstract the proton. So this is a substitution reaction and gives the amide. And alcohol as a byproduct. So acid plus amine do not form amide, but when ester react with amine in basic condition, again in basic condition, the reason is if I use acidic condition, what happened? So when ester and amine react in acidic condition, they do not form amide. The reason is this nitrogen contains a lone pair. This lone pair abstract the proton. Because this lone pair is labile, highly reactive lone pair because of the low electronegativity of nitrogen. And what we get? Salt. If suppose I have added HCl, gives the hydrochloride salt. Now this hydrochloride salt no longer remain as a nucleophile. Now this is not act as a nucleophile because lone pair get protonated. Lone pair get protonated. If you observe in mechanism what happened, this lone pair attacks on this carbonyl carbon. But when I add the acid in the reaction, this lone pair get protonated. Now there is no any lone pair present on this protonated ammonium salt. and this will not act as a nucleophile. Hence, not forms amide. So if I want to form amide from ester and amine, I have to add base, not an acid. Because as we know, acid-base reaction is among the fastest reaction. To form amide, we have to carry out which reaction? If I want to form amide from ester and amine, which reaction I have to carry out? Acid-base substitution, which reaction? This is very important concept. Which reaction I have to carry out? Of course, substitution, very good. I have to carry out substitution reaction. And it is only possible in case of base. Now in this case, substitution reaction is not possible because now this nitrogen do not contain lone pair. Because nitrogen has only one lone pair and this lone pair get protonated. And this says the hydrochloride salt is no longer act as a nucleophile because it is get protonated. The lone pair get protonated. And if you observe the mechanism, the lone pair is act as a nucleophile, attacks on this carbonyl carbon. But in this species, we don't have a lone pair on this nitrogen. That's why in acidic condition, amine plus ester, they do not form amide. Is it clear? Is it clear? I hope so it is clear. So which reaction we have to carry out to form amide from ester and amine? Substitution. Okay, and which is the fastest reaction? Acid base, then substitution, then the elimination, substitute, acid base, then addition, then substitution, then the elimination, and last one is rearrangement. And this is the order of reaction. So acid base reaction is among the fastest reaction, then addition, then substitution, then the elimination, and the last one is rearrangement. Because acid base reaction requires lower activation energy. So let's see the mechanism. How this amine and ester, they form amide. Is it clear? Is it clear? Okay, so let's move further. And keep remember, so this is as amide formation in basic condition, and this reaction is a reversible. This reaction is a reversible reaction. So this is very important. So this is a reversible reaction. So when amide react with the alcohol in presence of base, they gives ester and amine. The reason is this is a base. The base will abstract first the proton from here. So what we get? O alkoxide ion. Now this alkoxide ion is a good nucleophile as well as a good base. So this is a base as well as the good nucleophile. So it will attack on this carbonyl carbon, pi bond is break, form again, and this will eliminate it. Okay, so that's why, so amide formation from ester and amine in presence of base is a reversible reaction. At this point, we have discussed that ester and amine in acidic condition, they do not form amide. Okay, let's see how this reaction is possible. So let's discuss the mechanism of amide formation. So first, let's write the ester. Now this ester react with amine. React with amine. What happened in the first step? This nitrogen contains one lone pair, and the lone pair is a source of electron, act as a nucleophile. The lone pair present on the nitrogen is labile because of the low electronegativity of the nitrogen. This carbonyl carbon is a electrophilic in nature. Okay, so this lone pair attacks on this carbonyl carbon, and this pi bond is break. And leads to the formation of tetrahedral intermediate. You get this molecule. So this is a tetrahedral intermediate. And nitrogen is used this lone pair to form a bond between carbon and nitrogen. That's why there is a positive charge on the nitrogen. And this is a sterically hindered. So of course, this reaction is a steric sensitive. So first step is a slow step. First step is a slow step. The first step is a rate determining step. So this step is a rate determining step. ओके, ध्यान से सुनिएगा मैं क्या कर लिखने जा रहा हूं, ठीक है. Now when this electron comes back, there is a two possibility. One, this will leave, we get these two molecules. So when this will leave, I get these two molecules. When this OR minus is leave, what I get? R, C double bond O, so OR get leaved, NH, R double bond, R double dash. This proton get leaved, so I get this molecule. Okay, and what here leaved is OR dash. As I said earlier, this OR dash is a good nucleophile. If this OR dash attacks on this carbonyl carbon, because it is a good nucleophile, this pi bond is break, we get this structure. And that's why it is a reversible reaction. That's why it is a reversible reaction. So here again, this nucleophile when attacks on this carbonyl carbon, we get the tetrahedral intermediate. So this backward step is slow step. But this forward step is a fast. because here this OR minus is leave. OR minus is leave. And this reaction generally carried out in presence of base. In presence of base. So first step in amide formation from ester and amine is a rate determining step. So in the first step, what happened? This lone pair attacks on this carbonyl carbon, gives tetrahedral intermediate. Now this tetrahedral intermediate has two possibilities. When this electrons comes back, there is a two possibilities. One, OR minus get leaved, you get this step. So here OR minus is a leaving group. If this part will eliminate, we get these two structure. That's why this is a reversible reaction. If OR minus, OR dash is leaved, reaction occur in the forward direction. This amine is leaved, reaction goes in the backward direction. So this is a concept of amide formation. Why amide formation by ester and amine is a reversible reaction. So this lone pair is basic enough to attach on this carbonyl carbon, and this OR minus is a nucleophilic enough to attach on this carbonyl carbon. That's why this reaction is a reversible reaction. Is there any doubt? Is there any doubt in this mechanism? Any step they could not understand? Okay. So let me write the second mechanism. This is just for your understanding why this reaction is a reversible. Okay. So this is ester react with amine. The first step, what happened? Lone pair present on the nitrogen act as a nucleophile, attacks on this carbonyl carbon. This pi bond is break, and we get the tetrahedral intermediate. We get the tetrahedral intermediate. As I said earlier, when this electron comes back, maybe OR dash is leaved, alkoxide group is leaved, maybe amine leaved. That's why this step is a reversible, and the step is slow, and the backward reaction is a fast. Now the next step is a proton transfer. Because this O minus is basic enough to abstract the proton from here. So this O minus abstract the proton from this positively charged nitrogen. Because nitrogen is electronegative element, it never keep positive charge on it. It immediately withdraw the electron from this sigma bond between carbon and hydrogen. So this is a proton transfer reaction. So what happened here? OH, OR dash, here we get NH, atom dash. Is it clear? Is it clear? So maybe in a reversible step, this nitrogen lone pair takes the proton from here. So that's why this step is also a reversible step. Of course, the backward reaction is slow. Of course, the proton transfer is fast reaction because this nitrogen contains the lone pair. This lone pair abstract the proton from here and get the negative charge on the oxygen. This is a backward reaction. But this backward reaction is a little bit slower than the forward reaction. Okay. Now, next step, what happened? Now we have carried out the reaction in presence of base. So base will abstract the proton from this OH. So base abstract the proton from this OH. We get this structure. The next step, what happened? When this electrons comes back, this will be lead. Okay. And what we get? Amide and alkoxide ion. This alkoxide ion is basic enough, even nucleophilic, and attacks on this carbonyl carbon. We get this structure. This step is a reversible step. So the forward reaction is a fast, because in backward reaction what we get tetrahedral intermediate. That's why this is a slow reaction. And the overall reaction is a reversible reaction. Overall reaction is a reversible. Is it clear? Is it clear? Okay. Another mechanism you can write in this way also. So I will write directly this step. So minus, here we have OR dash. So you can write the mechanism in many ways, okay? Now the base will come and base abstract this proton. And what we get? This structure. And what happened in the final step? Which is reversible. This electron comes back, OR minus get linked. And we get the amide. This is another way to write this mechanism. And alkoxide ion is a living group. This is our living group. Which is known as alkoxide ion, which is basic as well as nucleophilic. Basic as well as nucleophilic. So when it attacks on this carbonyl carbon, we get this structure. That's why it is a reversible reaction. If in forward reaction, this OR minus is leave, that's why it is a fast step. And this is the tetrahedral intermediate. This is always steric sensitive. So when OR dash is leaved, the steric bulk get decreases. So this is not that much steric. Okay, so this molecule is a little bit sterically less sterically hindered, while this intermediate is more sterically hindered. So your species initially more sterically hindered. After the elimination of this OR dash, get less sterically hindered. That's why this step is fast. Now initially your reactant molecule is less sterically hindered and converted into the more sterically hindered molecule. That's why it is a slow step. So reversible step is a slow step. So there is another way to write this mechanism. This is a very important concept. So I have write this mechanism in very short. You can also write this mechanism in your examination. Because we have carried out this reaction in presence of base. So base easily abstract this proton, because now this proton is highly acidic. Highly acidic. So base will abstract this proton easily, as I shown here. So base easily abstract this proton. Give this tetrahedral intermediate, which involves the fast elimination of alkoxide ion and gives the product that is amide and alkoxide ion. So this is the mechanism of amide formation from ester and amine in basic condition. As I said earlier, this reaction is not possible in presence of acid, because this is a substitution reaction. So or in the product, this OR dash alkoxide ion gets substituted by amine. OR dash or alkoxide ion gets substituted by this amine. That's why it is known as a substitution reaction. But in presence of acid, as a catalyst, this amine shows acid-base reaction and forms a salt. And this formed salt is not a nucleophilic in nature. That's why the reaction cannot proceed in the forward direction, as we have discussed earlier. Is it clear? Or is there any doubt in this mechanism? So if you observe here, in presence of acid as a catalyst, this amine forms salt. And this salt is not a nucleophilic in nature. So reaction cannot proceed in the forward reaction. Clear? Shall we move further? Shall we move further? Is there any doubt? So in the first step, what happened? Nucleophilic attack by amine to the carbonyl carbon to form a tetrahedral intermediate. And this compound undergo the proton transfer, as I shown here. Sweet. And this intermediate, that tetrahedral intermediate, you can write the mechanism in many different ways. So this tetrahedral intermediate shows the proton transfer reaction. And the base abstract the proton, give this intermediate. Still, it is a tetrahedral intermediate, which involves the fast elimination of alkoxide ion and gives the amide. So when you neutralize the final product, you get the alcohol and amide. So after the neutralization, what we get? Alcohol and amide. Okay. So after the neutralization, when you carry out the neutralization reaction, that means the workup, water workup, when you carry out the water workup, you get amide and alcohol. Amide and so this is the mechanism of formation of amide from ester and amide. Again, in this mechanism, we have involved a tetrahedral intermediate. Okay. So again, we have involved tetrahedral intermediate in the mechanism. So this tetrahedral intermediate this is the intermediate is involved during the reaction. And this tetrahedral intermediate is sterically hindered as well as it is a negatively charged. So if I use some groups which is electrovitrual, if I use some group like electrovitrual groups which increases, so electrovitrual group increases the rate of amide formation. Because these electrovitrual groups stabilize this tetrahedral intermediate. Hence, the formation of this intermediate is faster, and that's why the amide formation is also faster. So if I use some electron donating group, then the rate of amide formation get decreases. Rate of amide formation get decreases. So as we know that the electrovitrual group generally stabilize the negative charge. So if I have a negative charge, suppose on carbon, if I attach some electrovitrual group, so this electrovitrual group generally stabilize this negative charge. So this negative charge is stabilized. But if I did the reverse thing, if I add some electron donating group, then this negative charge is destabilized. Same concept we have used here. If I substitute this carbon by electrovitrual groups, it increases the rate of amide formation by stabilizing this intermediate. This is the concept. Is there any doubt in this mechanism or in the concept how we can increase the rate of formation of amide? Okay, let me take the example. Suppose I have a CH3, this is the ester, and second molecule, if I use some electrovitrual group litro, and now I'm going to use some electron donating group like methyl. Suppose I number this molecule as 1, this is 2, this is 3. Now you have to tell me increasing order of amide formation. Increasing order of amide formation. Which ester among these three gives fast esterification? Let me give the option. The first will give fast esterification, then the second, then the third. Option B. Second, first, and third. Option C. Third, second, and first. Option D. All having equal rate. The rate of amide formation. Tell me. Rate of amide formation. Take your time, don't worry. Use the concept that we have learned. Apply the concept. चैट बॉक्स में सबको आंसर देना है, सबको आंसर देना है. Give your answer in chat box. Option B. Okay. चलो एक आया ऑप्शन मेरे पास, ऑप्शन B. Dan, any other? All you have to give the answer in chat box. सबको आंसर देना है, एक स्टूडेंट को नहीं, सबको आंसर देना है. गलत हो जाएगा तो कोई बात नहीं, गलती से हम सीखते हैं. All you should answer. आयुष says B. Okay, very good. चलो B ऑप्शन आ रहा है. दो एक ही ऑप्शन आया अभी तक मेरे पास, B ऑप्शन. बताते जाइए. B ऑप्शन, B ऑप्शन. और कोई ऑप्शन आ रहा है? ऑप्शन B, ऑप्शन B, ऑप्शन B, ऑप्शन B, ऑप्शन B. वेरी गुड. यानी कि आपको समझ में आ रहा है which option is right? Option B. Okay, because this is among the most electrovitral group, so it will increase the rate of formation of amide. It increases the stability of this tetrahedral intermediate, as well as it also increases the electrophilicity of this carbon, because it withdraws the electron towards itself. So this nitro group increases the electrophilicity of this carbon. But what happened here, this methyl group is electron donating group, so it donates the electron towards this carbonyl carbon, and this methyl group decreases the electrophilicity of this carbon and also decreases the stability of this tetrahedral intermediate. So your option is right. 2 will give fast amide formation, then the first, then the third. Okay, absolutely right. Okay, is there any doubt in this amide formation? Is there any doubt in this amide formation? Okay, so let's move on the next part, that is a hydrolysis of amide. So till now what we have discussed, the amide formation. So we have taken the ester and amine, add the base, and what we get? Amide and alcohol after the neutralization. The next process that we are going to learn is a hydrolysis of amide. And hydrolysis can be takes place in presence of acid as well as in presence of base. But both are irreversible reaction. Both are irreversible reaction. So when amide, this is amide, when this amide get hydrolyzed in presence of base, so hydrolysis of amide is an irreversible reaction. Irreversible reaction. What the product we get here? Acid, but I write carboxylate ion and ammonia. Initially it will give acid, but in presence of base this proton get abstracted and gives this carboxylate ion instead of carboxylic acid. Okay, so the product of amide hydrolysis in presence of base as a catalyst, the product is carboxylate ion and ammonia, and this is a stable molecule. So when I add the water molecule, or add the water, so this carboxylate ion absorb the proton, gives the acid and ammonia. And we know that this ammonia, is basic in nature. And this proton is highly acidic in nature. So this lone pair abstract this proton. What is our product? That is ammonium salt. This negative ion is stabilized by NH4 plus. This is also stable. Also stable. So this is a base catalyzed amide hydrolysis. This is a base catalyzed amide hydrolysis. And it is a bimolecular reaction. The rate of this amide hydrolysis depends on concentration of amide and concentration of base. So the rate of amide hydrolysis depends on concentration of amide and concentration of base. That's why it is a bimolecular reaction. and the order of the reaction is a second. So it is a second order reaction. Second order reaction. Okay. So whether it is a acid catalyzed or base catalyzed, we always get the stable salt. We always get the stable salt. And that's why both in acidic and in basic condition, amide hydrolysis is an irreversible reaction. Is a irreversible reaction. So let's discuss amide hydrolysis through BSC2 mechanism. BSC2 mechanism. So what means of BSC2? It is a base catalyzed acyl oxygen bond breaking to stand for bimolecule. Bimolecule approach. So let's see the mechanism of amide hydrolysis in presence of base. So this is amide, and the first step, the OH minus, because it is a base catalyzed. So base like OH minus first attacks on this carbonyl carbon, this pi bond is break, and what we get, tetrahedral intermediate. Here we have OH. So this is a slow step because from less sterically hindered molecule to get more sterically hindered molecule. That's why this step is slow step, and it is a rate determining step. And this is a reversible reaction. First step is a reversible reaction. Okay, why it is reversible reaction? Because when this electrons comes back, again here there is a two possibilities. NH2 minus can leave or OH minus can leave. If the OH minus can leave, we get this step. If this NH2 can leave, reaction proceed in the forward direction. Here we get OH and NH2 minus. And this reaction in this step is also reversible step because this NH2 minus is a nucleophilic. It attack on this carbonyl carbon and we get this tetrahedral intermediate. That's why this step is also reversible step. Okay, so what happened here? The next step, this NH2 minus also abstract this proton or also attack on this carbonyl carbon. If attack on this carbonyl carbon, we get this tetrahedral intermediate. If this NH2 minus abstract this proton, reaction proceed in the forward reaction, and what we get that we have discussed earlier, stable ion. So this is a stable ion. So these two steps are reversible step, but the last step is a fast step, is an irreversible step. Because this carboxylate ion is not act as a electrophilic in nature. Okay, is it clear? Because of the resonance, why this ion is not act as a electrophilic in nature? Because this negative charge in the resonance with this carbonyl group, like this, get this structure. So the electrophilicity of carbon decreases due to the resonance. Okay, that's why the last step is a reversible step, irreversible step. Last step is a irreversible step, while first two steps are reversible step. And that's why the amide hydrolysis in presence of base is irreversible reaction, because the last step is irreversible. Last step is irreversible. Okay, so today we are stopped here. In the next class, we will continue with this amide hydrolysis, and we will discussing ASE2. That means acid catalyzed acyl oxygen bond breaking unimolecular. Okay, so in this class, what we have discussed the amide formation and its mechanism, and we have discussed that amide cannot form from ester and amine in presence of acid. It's only formed in presence of base. And this is a reversible reaction. Means amide formation from ester and amine is a reversible reaction, while amide hydrolysis is an irreversible reaction irrespective to the catalyst. And ester and amine, they do not form amide in presence of acid, because it shows the acid-base reaction and forms a stable salt. This stable salt will not act as a nucleophile. So ester and amine forms amide only in presence of base. This is a reversible reaction. This point you have to remember. And we have also discussed the mechanism of this amide formation. Then we have started the amide hydrolysis. Okay. Amide can be hydrolyzed in presence of acid as well as in presence of base, but both reactions are irreversible. Okay, both reactions are irreversible. Okay. Is there any doubt? Is there any doubt? Is there any doubt regarding this topic? Okay. Till then, thank you very much, all of you. Have a pleasure learning of organic chemistry. Thank you to join online. See you soon. Thank you.